Hi guys, today we will be talking about the most common integration rules, and we will be specifically focusing on trigonometric functions. Now, if we recall what we know about derivatives, we know that d dx of sine x equals cos x. And therefore I can write the following statement. The integral of cos of x dx equals sine x plus c. Okay? And that's all our first integral that we need to know. Now, our second one, d dx of tan x equals secant squared x. So therefore, I can write the following statement. The integral of secant squared x dx must equal tan x plus c. So here is my second integral that we need to know. Now for a third, d dx of secant x equals secant x tangent x. We know that from derivatives. And therefore, I can write the following statement. The integral of secant x tangent x dx equals secant x plus c. And not only that, we also have more trig rules. So we know that d dx of cos x equals negative sine x. So if I take the integral of sine of x dx, that's going to equal not cos x, but negative cos x plus c. Which makes sense, right? Because if we take the derivative of negative cos x, we get negative sine x, which is sine x. Now, d dx of cot x, we know, is equal to negative cosecant squared x. And therefore, I can say the integral of cosecant squared x dx equals negative cotangent x plus c. And then finally, our last integral that we need to know regarding trigonometric functions is d dx cosecant x equals negative CSCX, or negative cosecant x, cotangent x. And therefore, I can say the integral of cosecant x times cotangent x equals negative cosecant x plus c. So here are 6 more common trigonometric functions that we need to know their integral. So we have cos x, secant squared x, secant x tangent x, sine x, cosecant squared x, cosecant x cotangent x. And these will be the main ones that show up. And we will do now a couple practice problems to get familiar. So let's say I have the integral of 1/3 cosecant x dx. Well, I know I can take out that 1/3. And I know the integral of cosine x is sine x. So this equals 1/3 sine x. And don't forget plus c. Another example we can do is the integral of e times pi times secant x times tangent x dx. Well, I can take out that e pi because it's technically a constant, and now write it as secant x tangent x dx. Now notice I have a form that we like. We know that the integral of secant x tangent x dx is secant x, because the derivative of secant x is secant x tangent x. So now this equals e to the e pi secant x plus c. Let's try doing the integral of pi squared sine x dx. Well, pi squared is a constant. I can take it out. And I know the integral of sine x is negative cos x. So this is going to equal negative pi squared cos x plus c. And here were 3 good examples of problems that involve trigonometric functions. And in the next video, we will go into more common rules about integration, specifically inverse trigonometric functions. But for now, we have just covered trigonometric functions and their integral rules.